Hey everyone, and welcome to our lesson on translated exponential growth functions and the growth formula. The first thing we're going to do is take a look at growth functions and the types of numbers that are added or subtracted that cause the translations. So when you see a function in the form f of x equals b to the x, where b is our base number, you'll know that you're dealing with a growth function when that b, that base number, is greater than 1. So when we see that, and then we see some numbers attached in these locations, other things are happening. So when we see that we have a number that is added or subtracted in with the power of x, that's going to cause a horizontal translation. When we see that a number is being added or subtracted outside of the operation, away from the base to the power, that's going to cause a vertical translation, up or down. And then if we see that a number's been attached to the base by multiplication, that's going to cause a stretch or a shrink. It's going to be pulling our picture in the y direction or compressing it in the x direction. We may also see a negative out there in front, and that would cause a reflection. Okay, so let's take a look at some examples. Here are some vertical translations. We know that because we can see that there have been numbers added or subtracted outside of our base to the power of x. So first one here, I have a growth function that has 4 added on the outside, which means a shift of 4 units up. Second one in the middle, I see that it's got 1 subtracted from it, so that's going to move it down instead, 1 unit. And then last one, the number is actually in front of the base to the power, but that doesn't matter. That's still outside of the power, so that's going to cause the vertical shift again, and it's being added, so it's going to move it up. Okay, here are some things that you may see if you have a horizontal translation. You'll see numbers added or subtracted in with that power. So here I have a 5 added, and that's actually going to cause a shift left. When you see a number added there, it's going to cause a left-hand move. And when you see a number subtracted, that's going to move our graph over to the right. So this bottom one has been moved over 1 unit to the right. Okay, last translation that we talked about, or transformation, was the stretch or shrink. So we have numbers here attached to the base of the power. And this top example is going to cause a stretch because it is a number bigger than 1. So it's going to pull it towards the y-axis, stretch it upward. And then the bottom one here, you can see we've got a 0.5 attached, and that's going to cause a shrink because that number is between 0 and 1. Alright, so let's take a look at what these pictures look like. We have a growth function here, and we know it's growth because the base is a number that's bigger than 1. And we can see that it's increasing from left to right, so that it's growing. It's a growth function. And let's say that we would like to translate this function. We would like to apply some translations of 4 units left, 2 units down, and we'd also like a stretch by a factor of 3. What would the new picture look like, and what would the new function look like? Let's work on that. So first, let's form the function expression. So we know that a stretch factor should go in front and attach to the base of the power, so let's put that in first. That would have a 3 attached to our 1.5 to the x. Okay. We need to apply a 4 units left movement, so we know that numbers inside with that x are going to cause the left and right movement. So since we want to move left, we're going to add 4. So we're going to add in 4 here. And then 2 units down, we're going to need to subtract 2 on the outside to make that happen. Alright, and if you have a graphing calculator, you can now type in this new function and hit graph, and it will give you a nice picture of what this new translated function looks like. If you don't, you can test numbers in for x and get matching y values to get your points to plot. Either way that you want to do that, you're going to see these movements applied. The new picture is going to look something like this. Same basic shape, it's still a growth function, but it's now been moved 4 units left, 2 units down, which causes that bottom level near the asymptote to move down to -2 instead of 0 where it started. And then you're going to see that it's been stretched by that factor of 3, so it'll just look a little taller, like it's been pulled up towards the y direction. All right. So if we're going to use these in real world scenarios, we're going to need to use the exponential growth formula, which you can see here. And we need to take a look and see what each piece represents so that we'll know where to put our information when we're working with it. So take a look here. Out front in this formula, a of t, that's going to represent your final amount. Little a inside is going to represent your initial amount, or the amount you're starting with before the growth has been applied. The r on the inside is going to be your rate of growth, and then the t is going to represent the time that has elapsed. All right, so we are going to do that. We're going to take a look at a real world problem and apply that growth formula. So suppose we have $1,000 to deposit into an account, and it's going to grow at an growth rate of 3%. And we would like to know how much money will be in the account after 10 years, just from that rate of growth being applied over the 10 years. How much money will we end up with? What will be our final amount? So what we're going to do is we're going to copy in that growth formula. A sub t equals little a, 1 plus r raised to the t power. And now we're just going to fill in our information into the places where it should go. So we don't know final amount yet. We're going to leave that part alone. We do know that we started with 1,000, so that's our initial amount. Inside the parentheses, we're going to put 1 plus our rate. But instead of putting 3, we're going to put 0.03, because if we are given a percentage, we need to move the decimal over 2 spots to the left in order to calculate with that percentage. So the decimal 0.03 will be what we're using to represent 3%. Okay, you always want to move that decimal over 2 spots to the left before you start calculating. All right, and we're letting this sit in the account for 10 years, so 10 is our time. Okay, to do this, we want to make sure we do the correct order of operations. So we're going to work inside parentheses first, adding that up, 1.03. Then we're going to raise that number to the 10th power. We need to take care of the powers first, and then we can multiply by 1,000. And when we do that, we should come up with an amount around $1,343.92 approximately. So pretty neat. We can see that with that rate of growth, we've earned around $343. All right, so this concludes our lesson on translated exponential growth functions and the exponential growth formula.